The GLAMS project is funded by ASI, the Italian Space Agency, and it's a partnership between the CISAS Center, which is the Center for the Study of Space Activity, of Space Activities of the University of Padua, the ICMATE Center of the National Research Center, and WASP, which is a company which is a world leader in the production of full-scale 3D printers. So now, why 3D printers? Because the goal of the GLAMS project is that of producing structural elements to be produced by additive manufacturing using 3D printing for the production of, as I said, structural elements which will be used to assemble lunar bases, with the idea of creating semi-permanent human settlement on the Moon, which is one of the plans for the near future of different space agencies. Okay, so basically these 3D printers will extrude cementitious binders. This cementitious binder will be made up of cement, which is produced directly by using the lunar regolith. Okay, the lunar regolith, which is basically not other than the lunar soil. So our idea is that we will not need to transport Portland cement, which is the common Portland cement used for construction on the Earth, from the Earth to the Moon, but we will exploit directly as a raw material the lunar regolith, the lunar soil available on the planet, on this satellite. This has two advantages. So the first advantage is that of saving both money and fuel for the transport of the raw material. Okay, so the first idea is minimizing the transport of material from the Earth to the Moon. And the second advantage is that because this kind of cement, this kind of binder, is more sustainable in terms of reduced CO2 emissions with respect to Portland cement. In fact, what we are going to use is called regolith simulant, which, as the word says, is a material, is a powder that simulates, that replicates those that are the properties in terms of chemical composition, mineralogy, and grain size distribution of the lunar regolith, of the lunar soil. Because the actual lunar soil samples that were brought back to the Earth during the Apollo missions cannot be used for such a project, because we would destroy them in using them to produce cement. We hope that with this project we can provide the technology that can be exploited by the different space agencies to create, as said, the basis for lunar settlement to be created on the Moon. And in particular, the extruded lunar cement will have properties by which this material can withstand the environment present on the Moon, such as, for instance, the very large differences in temperature occurring during the lunar day and the lunar night, that will provide this material with the possibility to withstand, for example, damage associated with freeze-thaw cycles. So it is enough talking. It is time now to roll up our sleeves and start working on the project, and hopefully we will have nice results at the end of the GLAMS project.